Alright. Hello. Today I'll be explaining how to solve question 17 from Energizing Physics lesson 4.6. So in question 17, you're given that a car can go from 0 to 60 miles per hour in 2.7 seconds, and that it can go from 200 to 0 miles per hour in 1.9 seconds. Right? And so what you're trying to find is the position versus time equation for when it's going from 0 to 60 and when it's going from 200 to 0. And so the important things to remember are that position is equal to 1/2 times acceleration times t squared plus initial velocity times t. And that acceleration is equal to v2 minus v1 over t. And so the important things, so you're already given what v0 is, and you don't need to know what t is because the equation is in terms of t. So all I need to solve for is a, for 0 to 60 and for 200 to 0. And so for the first acceleration, it's going to be 60 miles per hour over 2.7 seconds. But 60 miles per hour and seconds are not the same unit. Well, hours and seconds aren't. So you have to change this to by dividing it by 3,600, or 0.0167 miles per second. Right? And so the acceleration is equal to 0.0167 miles per second over 2.7 seconds, or it is equal to 0.00617 miles per second squared. Right? And so the position versus time graph for going from 0 to 60 is equal to 1/2 times the acceleration times t squared plus the initial velocity, which is 0, t. So this simplifies out, and you just divide the acceleration by 2 to get the position versus time equation of 0.00309 t squared. Right, and that's in miles. And so you do that again for the second acceleration. So it goes from 200 to 0, or a change of -200 in 1.9 seconds. Except again, you have to change the 200 back into miles per second. So -200 miles for 1 hour times 1 hour over 360 equals 0.056 miles per second. So acceleration is equal to 0.056 miles per second over 1.9 seconds, or it is negative, or it is equal to -0.0292 miles per second squared. And so again, you just plug it back into this equation. And so position equals 1/2 times 0.0292 times t squared plus the initial velocity, which is 200, t. And so again, you just divide the acceleration by 2. And the position versus time equation becomes -0.014 -0.0146 t squared plus 200 t. And again, that's in miles. And that's it.